Module 2, Lesson 3, Estimating Centers and Interpreting the Mean as a Balance Point. So our instructional outcome will be to interpret the mean as a balance point of a distribution. In exercises 1 through 2, they give us the following example of quarters taped to a lightweight ruler. So number 1 says Sam taped 3 quarters to his ruler. We can see our 3 quarters as being located as here at number 1, here at 9, and here at 11. So the quarters were taped to these positions. If the pencil was placed under the position 5, do you believe that the ruler would balance? So if I put my finger right here at 5, would it balance? Why or why not? So the students will be given an opportunity to think, pair, share, and discuss. Do they believe it will balance? Do they believe the ruler will tilt to the left? Or do they believe the ruler will tilt to the right? And different students will have different opinions, and it will be discussed for different reasons. And then the teacher is going to bring up if the ruler did not balance. So let's say it did not balance. If it did not, would you move the pencil underneath the ruler to the left, or would you move the pencil to the right in order to get it to balance? And then the teacher will give the students the opportunity to discuss and explain their answer. And there is no right or wrong answer right now. They're just theories and thoughts and ideas. And so what the students are going to experience in the next set of exercises is how to a little bit more precisely pinpoint what this balance point might be. So here we are in exercise 3. It says estimate a balance point for the ruler. So complete the following based on the position you selected. So in the last example or exercise, we said, what if it was at 5? Do you believe it would balance, yes or no? And if not, should I move the pencil to the left or should I move the pencil to the right? Let's just assume that I decide to move my pencil to the right by 1. So I went from 5 to 6. Now, students will be given an opportunity to choose any number that they want. So some students in class may have chosen 4, some might have chosen 6, some might have chosen 7, and a few may have chosen some other number just to kind of test what would happen. So in this scenario or situation, the position of quarter 1, they want us to fill in the distance from the quarter to the estimate of the balance point. So if I estimated my balance point here, this would be 1, 2, 3, 4, a distance of 5 to the left of that point. If I did 9, it would be 1, 2, 3. And if I did 11, it would be 1, 2, 3, 4, and then 5. Now, no one is saying yet the balance point is 6. This is just one theoretical position that a student may have chosen. So they ask in 4, what is the sum of the balances to the right of your estimate of the balance point? So if I look to the right of my balance point, the sum of that would be 3 plus 5, and this would end up equaling 8. And number 5, exercise number 5, what is the sum of the distances to the left of your balance point? And so the sum of that, well, since there's only one value on the left-hand side of my balance point, it would still be 5. So here we have a 5, and here we have an 8. In exercise 6, do you need to adjust the position of your balance point? And so if I'm using 6 as my balance point, I've got a distance of 5 on the left and a distance of 8 on the right as my sum, then I would probably assume, yes, I would need to move my balance point a little bit more to the right to help even these numbers out. We want these numbers ultimately to be the same. And then in number 7, it says calculate the mean and the median of the position of the quarters. That the mean or the median of the positions provide a better estimate of the balance point for the 3 positioned quarters taped to this ruler. Explain why you made this particular decision. So if we look at the mean, then to find that, all I would do is take 1 plus 9 plus 11, and I will divide that by 3. So 1 plus 9 plus 11 is 21. We'll divide that by 3, and we're going to get a mean of 7. If we looked at the median, the number that's in the middle, well, there's only 3 numbers, a 1, a 9, and 11. So our median would equal 9. And so then the question would be again, does the mean or the median of the positions provide a better estimate for the balance point of 3/4? Explain why you made this particular reason. And so students will have an opportunity to defend whether they think the mean or the median would be better in this given scenario. In this particular problem here, just to follow up, how do you think the quarter located at the 1-inch position affects the balance point? And if the quarter were moved to the position of 3 inches, what would happen to the balance point? And so we'll just look at that real briefly. If that quarter was moved to the 3-inch, what would that do to the balance point? And so then we would calculate that distance or average based on what that would be. For exercises 8 through 11, we bring up a new scenario. 22 students from the junior class at River City High participate in a walkathon to raise money for the school's band. The dot plot indicates the distances in miles of students from each class walked, shown below. So here we are, the junior class. And one thing that's interesting to note real quickly about the data is notice we have some over here. We have the bulk of the data over here to where we may describe that our skew, or the bulk of our data, tends to be over here. So we would have a skewed set of data with the tail being towards the left. So, and then here it is just a discussion. Answers will vary based on the student. It says simply to estimate the mean number of miles walked by a junior and mark it with an X on the junior class dot plot. How did you estimate this position? And so again, answers will vary. Chances are a lot of students will probably put something that's going to be in this region just because they see that's the middle of the graph, because they saw data on the left and the data on the right. Now, we haven't actually calculated the mean, and right now we're not going to because it's just an estimate. But that gives you an idea of what some students will probably be thinking in the class. Then it says in number 9, what is the median for the junior class distribution? And so the students would be thinking, this one they could usually tend to pinpoint because they'll start to mark a dot here, they'll come over here and mark a dot over here, they'll go a dot here, they'll mark a dot over here, and they try and work their way out to the middle. And a lot of times they will deduct and reason that the median is going to be 8.5. In number 10, it says, is the mean number of miles walked by a junior class less than, approximately equal to, or greater than the median number of miles? If they are different, explain why. And if they're approximately the same, explain why. So in this case, following up like the last lesson we talked about, the mean, which is over here, would be less than the median, which would be found over here, because the median is like generally in this area. Why is that the case? Because a lot of our data is over here with a skew and a tail towards this direction. And so when we have that, the median is typically a better number to go with, and because of the bulk of the data is to the right, then our median will be pushed further to the right as opposed to being pushed to the left. In number 11, how would you describe the typical number of miles walked by a junior in this walkathon? And so we know already that the mean or the average appears to be an underestimate because it was way over here towards the left. And so we would say that only 7 students walked less than the mean, while 15 students, or the bulk of the students, walked more. And so the median, which is where the majority of the students are in this region right here, and so the median at 8.5 would be a better estimate to describe what a junior walked in this walkathon. Finally, when we look at this here, where 25 sophomores also participated. In this one, one thing that's a stark difference in interest is you've got all the data here, and you've got another half of the data over there, and there seems to be nothing in between. And so we start to look at this, and they say, what is different about the sophomore data distribution compared to the data distributions for juniors and seniors? Well, it's a U-shaped distribution. In other words, half of the sophomores were on the low end, walked 1 or 2, while the other half of them walked 9 or 10. There was none that really walked anything in the middle or just have an average deal. And so that's one thing that is interesting in this particular piece. So if we looked at question 18, estimate the balance of the sophomore class distribution. And so if we were to balance out and solve it out, or basically find the mean, then the mean or the average would be somewhere here around 5. Now clearly no one walked 5, everyone either walked 1 or 2 or walked 9 or 10. But if we did average everything together, we would end up somewhere around that 5 mark. What is the median number of miles walked by a sophomore? And so if we did the median value, since there are 25 values or 25 sophomores, the median is the 13th value from the left or the right, and in this case, if I went through each one, it turns out here that the median value would end up equaling 2, just based on what it followed. If I put them in order and took one out from left and right until I got to the last one left over, I would end up with a 2. And then question number 20, how would you describe the sophomore data distribution? Well, it's a U-shaped distribution. I mean, we got either a very low set of numbers or a very high set of numbers. Nothing was in the middle here. So the values are either small or large. The mean and median are not good indicators of either one of these data, because very clearly this is not a good indicator of what a typical sophomore wrote or walked, and then saying the median 2 being, let's just say right here, is also not a very good indicator of what the typical sophomore had wrote. So there are cases via this example where neither one is really a good fit in this design. So in closure, our lesson summary, the mean of a data distribution represents a balance point for the distribution. The sum of the distances to the right of the mean is equal to the sum of the distances to the left of the mean. And we saw that when we worked with the ruler and the 3 quarters taped to the ruler.